Welcome to The Explainer. Today, we're diving into a seriously fascinating thought experiment. We're going to hypothetically wipe humanity right off the face of the Earth. Why? Well, to really grasp the sheer immense scale of our everyday impact on this planet. Okay, let's dive into this. If humanity just vanished tomorrow, what would be our longest-lasting fingerprint? Now, I know, it's a super dramatic premise, but exploring a world without us is actually the most direct, eye-opening way to understand exactly what we're doing to the world right now.
Just picture the visceral scene of that immediate aftermath. We simply vanish. Almost instantly, those massive pumps that keep our subways and cities dry, they just stop humming. But our physical infrastructure, the concrete, the steel, and crucially the fences, they stick around. Our boundaries actually outlast us, effectively trapping the natural world in a cage of our own making. Here's the roadmap for this explainer. First, Earth without us. Second, the fate of our livestock. Third, the fall of infrastructure. Fourth, the longest hangover, carbon. And finally, our deep time legacy.
So, Part 1. Earth without us.
The clock starts ticking incredibly fast. After just 2 days, literally 48 hours without active maintenance, New York City's subways flood completely and become totally impassable. 7 days in, the emergency generators pumping coolant into the world's 450 nuclear power plants run out of fuel, and well, they begin to melt down. But skip ahead to 1 year, and we see this incredible irony. Human head and body lice go completely extinct, and those cockroaches in temperate cities, they actually freeze to death. It turns out these so-called resilient pests depend entirely on our heated, artificial environments just to survive.
Part 2. The fate of our livestock. Before natural selection even gets a chance to kick in, our farm animals hit a massive physical bottleneck. Millions of miles of wire and mesh fences are still standing strong, so these animals are trapped in enclosed lots with super limited access to safe water or any alternate grazing. On top of that, there's a critical lack of fertile breeding males since, most male farm animals are gelded. This physical trap basically results in rapid, massive pestilence simply from starvation.
Now, what's really interesting here is the stark contrast in who makes it and who doesn't. On the survivor side, we have feral pigs. They're notorious escape artists who will absolutely dig under fences to get out. Beef cattle might actually make it too, provided they can break free and find some grass. But on the doomed side, we've got the animals that have been heavily manipulated by artificial selection. I'm talking about wool sheep and dairy cows.
And this brilliantly illustrates how the specific traits we bred into these animals become absolute fatal flaws without farmers around to manage them. Take wool sheep, for example. They've been bred to never, ever stop growing fleece. Without yearly shearing, they literally go wool blind, become completely immobile, and eventually succumb to fatal infections. And dairy cows? They've been engineered to produce up to 10 gallons of milk a single day. Without milking, all that milk just sits there, causing deadly infections. Even chickens, which are actually genetically pretty close to wild stock, would face a massive early population boom, rapidly eat every scrap of available food in their enclosures, and then just face mass starvation. It's a tough reality.
Okay, Part 3. The fall of infrastructure. It's honestly wild to look at how quickly nature reclaims our grandest concrete and steel achievements. At just 3 years, pipes in colder regions burst, flooding out cities, and buildings lose their structural integrity as they expand and contract with the wild temperature swings. Fast forward to 20 years, and the Panama Canal completely closes. It just silts up and overgrows with wild crops, literally rejoining North and South America geographically. No way, right? And if we jump to 300 years, most of the world's major bridges have fallen, and dams have silted up and overflowed, completely washing away entire cities in the process.
Let's move to and see how this builds in Part 4. The longest hangover, carbon. To really grasp this, we need to clearly define the carbon cycle's two main domains. First, you've got the fast domain. This exchanges carbon over years to centuries. Think the atmosphere, vegetation, and the upper ocean. Then you have the slow domain, which takes millennia to millions of years, locking carbon away deep in rocks and deep-sea sediments. Basically, through our industrial actions, digging up all that coal, oil, and gas, we've essentially taken massive amounts of carbon from the slow domain and just forcefully injected it right into the fast one.
The sheer amount we've moved is honestly staggering. 555 petagrams of carbon. To put that into perspective, just 1 petagram is a billion metric tons. This single massive number represents our total cumulative carbon emissions from fossil fuels, cement production, and land use changes between 1750 and 2011, directly according to the IPCC report.
Now, what's really interesting about this slide is the incredible timeline of how the Earth actually digests all this excess carbon. Because we've completely overwhelmed the natural buffer system, depending on the scenario, anywhere between 15 and 40% of our emitted CO2 is going to remain in the atmosphere for over 1,000 years. Let that sink in.
Let's break down the epic geological odyssey of how a single CO2 molecule is naturally removed. Phase 1 is what we call ocean invasion. Over decades to centuries, the ocean absorbs a huge chunk of that CO2, but this rapidly increases ocean acidification. Then, Phase 2 takes thousands of years. Here, the ocean's pH is slowly restored by reacting with calcium carbonate sediments way down at the bottom of the sea. And finally, Phase 3 takes hundreds of thousands of years. This is silicate weathering, which is this incredibly slow chemical reaction between the CO2 in the atmosphere and igneous rocks on land. 100,000 years. That is how long it'll take for these natural sinks to completely remove the human-emitted CO2 from the atmosphere and finally return it to pre-industrial levels. This incredibly long recovery time is exactly why climate change caused by elevated CO2 is considered completely irreversible on a human timescale. It's a one-way street for us.
Which brings us to part 5, our deep time legacy.
Look at what truly outlives us. At that 100,000-year mark, as atmospheric CO2 finally normalizes, microbes will have likely evolved to fully biodegrade all our plastic waste. And get this, the plutonium from the bombs we made during the age of humans finally becomes safe to handle. But if we fast forward a staggering 10 million years, our steel cities are absolute dust, but bronze sculptures actually remain recognizable. The granite faces carved into Mount Rushmore will still be staring out across the continent.
So the crucial point is this. If Mount Rushmore and our bronze sculptures outlast our cities, and our carbon emissions outlast our civilization, what kind of legacy do we want to leave right now while we are still here? We are literally writing a permanent geological footprint into the Earth's history every single day. Understanding what happens to the world if we leave, well, it should ultimately change how we choose to live in it right now. Thank you so much for joining me for this explainer. I really hope you learned something fascinating today, and I'll see you on the next one.